So we have here another question. Complete. ARIMA 3, 2, 4 model. For this ARIMA 3, 2, 4 model, our autoregressive part is of order 3, our moving average part is of order 4, while the differential part is just 2. Now, the first thing to do is to write the autoregressive part of order 3. Autoregressive of order 3. Autoregressive part of order 3 will give us 1 minus phi 1, the backward shift 1 minus phi 2, the backward shift 2 minus phi 3, the backward shift 3. Also, the differential part is of order 2. We have differential of order 2, which is 1 minus b raised to the power of 2. Now, the moving average part is of order 4. The moving average part is of order 4. So we have m a moving average of order 4. Will give us 1 plus theta 1b plus theta 2 b2 plus theta 3 backward shift 3 plus theta 4 backward shift 4. So this is what we have. This is what we have. Now, the next thing to do, we say we recall from what we have as our model. Our ARIMA model says that we have 5p b, our differential of order d, xt to be equal to theta of order q et. So these are ARIMA models. This is exactly our ARIMA model. So whatever we have here, we will write it in this form. Whatever we have here, we will write it in this form. When we write it in this form, it means we have found the model for ARIMA 324 computation. So the first on our list is the ARO part. That means this part. This part is what we first write. We write it this side. The ARO part is 1 minus phi 1 b minus phi 2 b2 minus phi 3 b3. Then multiply by the differential part. Our differential part is 1 minus b raised to the power of 2. We also have our xt part, which is the time change xt, which is equal to, now we have the MA part, the moving average part, which is of order 4. So we write it as, which is 1 plus theta 1b plus theta 2b squared raised to the power of 2. Or we put it here, we say plus theta 2 b raised to the power of 2 plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that's what we have. That's what we have. That is simply our model. That is simply our model. If we can compare it with what we have here. Now, but we can still write this out properly. So it will be very easy for it to see. So we say no. We have to know that 1 minus b all squared xt is equal to, so for that multiplication, we can expand this to give us 1 minus 2b plus b squared. Then multiply by xt. Multiply by xt. You can use this xt to multiply the whole of this to give us xt minus 2 bxt, this multiply like this plus b square, that means the backward shift xt. We have already talked about how we can compute the backward shift in our previous lesson. Now we have this to be equal to xt minus 2. Because of the backward shift, we write it as xt minus 1 plus, because of the backward shift raised to the power of 2, we have xt minus 2. And this is the same thing as equal to xt. We can say, let's take it as this xt double prime. So we have this to be xt double prime t. So that means we can rewrite whatever we have here back. So whenever we see this, we put this. Whenever we see the one of this, we put this. So that means that our model will now be 1 minus phi 1b minus phi 2b minus phi 3b 3, then x t prime prime to be equal to, because the whole of this is this, to be equal to 1 plus theta 1b plus theta 2b squared plus theta 3 b raised to the power of 3 plus theta 4 b raised to the power of 4. So that is it. The next thing we do is to expand whatever we have here. We open the brackets. Then this, okay, this is ET. We put our ET here. And this, we also put our ET here. Sorry. We put our ET because we have the ET in our model. So that is it. This is our model. This is our model for ARIMA 324. We are only trying to expand this to open it. For me to do that, we have to use the backward sheets and the pressing part to be equal to this. Since this is equal to this, so whenever we see the whole of this, we put xt double prime. So we expand that. For me to do that, we move over to this side of the board to do that. So we can open this. If you open it, we have xt prime prime. That means if we multiply this by this, we have xt prime prime minus phi 1 x t t minus 1 minus phi 2 x t minus 2 prime prime minus phi 3 x t minus 3 prime prime to be equal to, now if we multiply et by this, we have first et plus, if you multiply et by the second one here, that means theta 1b, we have theta 1 et minus 1 plus theta 2 et minus 2 for the second one plus theta 3 et minus 3 for the third one plus theta 4 et minus 4 for the fourth one, because we have a moving average part of order 4. Now, it then means that we can make this the subject of formula. We can make this the subject of formula to write it as st to be equal to, that is st prime prime to be equal to this. If you move the whole of this part to this other side of the equation, you have it as positive. So it will be phi 1 xt double prime plus phi 2 xt prime prime minus 2 plus phi 3 st minus 3 prime prime plus, we start with this. We can start with this. Theta 1 et minus 1 plus theta 2 et minus 2 plus theta 3 et minus 3 plus theta 4 et minus 4 plus et plus our error 10 or the white noise. So this becomes the model for the given ARIMA 324. This becomes the model for the given ARIMA 324. Or we can still write it as this, but expanding it, we write it as this. So for more on this topic, you need to subscribe to this channel to get more questions and more teachings on ARIMA model.